I put a couple of slides in just to give a little bit of background in terms of history. Let's see. Oh, there we go. So basically, this whole technology profile, speed profile idea kind of started from the VOLTHA technical lockdown in January of 2018 in San Ramon. So there's a lot of discussion around specific XPON technology that has kind of migrated its way kind of into the VOLTHA core. And the idea is that the VOLTHA core was designed to make that just basically completely technology agnostic, so that I could add OLT adapters that were, say, EPON or XPON or any other kind of technology, and the VOLTHA core itself would just remain the same and agnostic to that technology. So this is basically the WT385 model from the Broadband Forum that kind of migrated itself kind of into the VOLTHA core itself, as opposed to residing within the OLT adapter. You can see there's a lot of very useful information. It's kind of like a superset of PON. So it basically deals with the NG-PON2 technologies, but GPON or XGS-PON is kind of a subset of that, and it defines the TCONs and GEM ports, channel groups, channel pairs, channel terminations, and basically traffic descriptors for TCONs. So this had kind of embedded itself into the VOLTHA core, and kind of a decision was made to we'd like to kind of remove this and come up with an idea that a model where we didn't have to add very technology-specific things into the common code. So basically, Radisys and the ONF kind of worked together on a way to provide a set of technology profiles that could be applied independent of the VOLTHA core. So the technology profiles themselves are files that have information about a specific type of access technology. And those files are loaded into the VOLTHA database. And the idea is that when I create a flow using OpenFlow, so I define my match action rules on the UNI or NNI, and I then also reference a technology profile. So the technology profile deals with things like, for PON, it deals with things like the TCONs, ALEC IDs, GEM ports, things that VOLTHA, things that OpenFlow doesn't really understand or have a way of configuring. And so OpenFlow would have a reference. The idea was OpenFlow would reference this technology profile, and as the OpenFlow messages flow down to the OLT adapter itself, the OLT adapter would then take the reference to the technology profile and have access to the very, technology-specific aspects of the flow. Bandwidth profiles were kind of maintained separately from the technology profiles because they can be very variable, especially DSL-type technologies. There's a whole huge set of potential profiles. And the bandwidth profiles themselves are passed down to the OLT adapter and the ONU adapters themselves as meters. And OpenFlow has a concept of meters with, and you can find a number of meter bands. So that was the kind of the idea and kind of a little bit of history behind technology profiles. So this shows the initial. This is the initial model for a technology profile. So basically, the technology profile itself draws from standards bodies. So the ITU, the GPON, XGS-PON, and NG-PON2 standards, and also the Broadband Forum 385 and 383 standards also. Also, we added some what I call instance control to this. I'll explain that in a little more detail in the next couple of slides. So initially, the technology profile, the file itself, had an identifier, and the model we were thinking of originally was that we would use the OpenFlow table ID, would reserve a range. So in this case, we're kind of reserving the range of 64 to 255 table IDs. And normally, the OLT uses 2 table IDs for defining a flow. So we thought we had enough space, but looking at 64 to 255, it doesn't feel like it's a very large number of options here. But as it turned out, when an operator defines a service, like for instance a high-speed internet service, typically that service looks the same from subscriber to subscriber. The variable part of that is mainly the bandwidth profile, which is kind of separate from the technology profile. So the technology profile defines the bones of a service, or like a TCON, a gem port. It defines schedulers. It defines discard policies, a few other things that are specific to PON in terms of whether you want AES encryption on a gem port or not. And also things related to DBA scheduling upstream. So for instance, originally we had, when I create a service upstream, I apply a bandwidth profile to that service, and that bandwidth profile gets translated into a set of DBA parameters. One of those parameters is fixed bandwidth, which was originally in the technology profile, but after one of our lockdown meetings, we decided just to completely move that out into a regular media band type configuration. One of the additional parameters you could have is whether any excess bandwidth on the PON is allocated to a service either as non-assured bandwidth or best effort bandwidth. So this gives you a little bit more control over the upstream DBA scheduling models. And priority and weight there are for a scheduling model that's in the standards. It's not really used very much. So basically, if I have a set of services on a PON, I could give each service a priority and a weight and allow it to schedule like that. But it's not typically done like that. But in my experience. So the instance control was basically saying when I have a technology profile that's applied to an ONU port, it basically says, am I operating in TR-156 mode? So basically, is the TCON kind of like a class of service on the PON, or in the TR-280 mode is it an independent scheduled service? So there's a few options with from within the broadband forum standards. So if we look in this, so again, from this is all based on the broadband forum standards. So TR-101, TR-156, and 156 defines a 4+1 service model. TR-280 defines an enhanced QoS model that could be used also. So when I define my service, I apply a technology profile. I define an OpenFlow set of match action rules. I define the interface, and basically based on that information, the OpenOLT adapter in the ONU essentially creates TCONs and gem ports, and at the UNI interface, I have some match action rules. In this case, it's describing a best effort service. So I have a best effort service on UNI 1 here, and in the TR-156 case, I have a gem port per UNI per class of service that's associated with a TCON for that class of service. Potentially, if I have 2 best effort services on 2 different unis, they both share the TCON, so this guy is 50 meg, that guy is 100 meg, and the TCON gets 150 megabits of bandwidth to schedule. So on the ONU itself, you have to limit this guy to 50 and that guy to 100, just so they don't get greedy and take all the bandwidth that's possible there. Also, if there's any questions, just feel free to ask as well. This is an example of a TR280 service model. This is like the AT&T service model. So in this case, I have a technology profile that has a TCON with 4 gem ports. The technology profile defines the p-bit mapping to each gem port. It defines the scheduling policy between the gem ports. In this case, in AT&T's case, is a kind of a hybrid scheduling model where some gems are round robin, weighted round robin, some are strict priority, and basically the OLT actually gets the technology profile and the OpenFlow messages, and it generates the OMCI MEs down to the ONU to configure this service.
So the previous page basically is the multi-TCON scenario like Turk Telecom is trying to do, is that right?
So in the case, yeah, so if an operator wants to do TR-156 4+1 style services, then like in Turk Telecom's case, yeah, so I'd have a TCON per service, basically. And originally we were a little scared of defining lots of technology profiles, just given that range of values we could set from the table ID. But later on, we kind of expanded the range out to be 16 bits, so we don't really have that concern anymore. And that actually simplified quite a few things in the code, because where I showed the technology profile itself, we had this, we had kind of 2 instance control things, ONU and UNI. And the UNI control was there to say, okay, if I have a technology profile on a given UNI and I want to create another service on that UNI, I don't really have to create another technology profile. I can use the same one, right? Because the structure of the service is the same, right? If it was different, you use a different technology profile. But if it was the same, you could use the same one. But now we've just said, okay, because we have such a wide range of values we can use to make it simpler, if you want another service, you just use another technology profile. Okay. Let's see. So so if we talk a little bit about the speed profiles or the bandwidth profiles now, basically the model for bandwidth profiles is kind of like the MEF service model. So we have, CIR, CBS, CIR, EBS, and for PON we have an extra bandwidth component, which is a short information rate. So we did a mapping from the OpenFlow meters and meter bands. So the meter bands define a rate and a burst size. So each bandwidth component we need is a CIR, CBS. There was a meter band for it. Same with EIR, EBS, and same for AIR. So if we want all the possible bandwidth component combinations for a PON, so we'll talk about TCON types in a little bit, but so if we want to have all those different components, we need to have 3 meter bands, right? There may be some services like if it's just best effort, then you just need 1. But the meter bands allow us to define all the bandwidth components we need for the PON. So this just talks a little bit about on the PON scheduling. So basically, I need upstream. I need potentially fixed bandwidth, assured bandwidth, non-assured bandwidth, and best effort bandwidth. And this is assigned in kind of priority order in the DBA algorithm. So basically, fixed bandwidth is always assigned first, then the assured bandwidth, and then non-assured, and then best effort. So basically, I have the DBA algorithm is keeping track of demand and available bandwidth, and it basically allocates grants to alloc IDs on the PON, and it can allocate up to the max defined for the service. and it's all priority based on this ordering here. In the ITU G.984.3, they have the concept of TCON types, and a TCON type is basically a combination of traffic parameters that represent a certain type of service, right? So TCON type 1 is all fixed bandwidth. It's all guaranteed bandwidth on the PON. It's always there. So I really need one meter band for that one. Type 2 is like an AF type service, assured forwarding. In this case, the assured rate is the max, so there's no additional bandwidth I get. Type 3 is an AF type service, but it can get excess bandwidth above the assured information rate. Type 4 is just best effort, again, one meter band for that. And type 5 is basically a combination of all of those. So I can define a meter band for the fixed, a meter band for assured, and a meter band for the max bandwidth. And this other parameter that was kind of in the technology profile allows me to kind of override this default mode of operation for the TCON type. So normally for type 1, type 2, there's no additional bandwidth given. For type 3, I can define the non-assured bandwidth as the additional type of bandwidth. Type 4 is best effort. And type 5, I can specify any type I want. So the technology profile in case of type 5 allows me to say, I need this to be best effort. And downstream, it's kind of diff-serve type flow. So I have a CIR, CBS, CIR, EBS type service. So an example of a technology profile being applied. So this is AT&T's high-speed internet service example. So in this model, I have a TCON with 4 gem ports, and each gem is a certain traffic class, and the priority queue defines the priority of that particular gem port, and the p-bit assignment is defined there. So for each of those 4 gems, it defines which p-bits are handled by those gems, and the scheduling policy defines gem 3 and 4 here are strict priority, and 1 and 2 are weighted round robin. And then there's a weight parameter I can apply in the technology profile. Same thing for upstream and downstream. And the traffic type doesn't really matter. But, so this is a service, and then this is basically showing how that translates into the technology profile. Anything that's kind of stricken through here is basically something that we had defined originally that kind of we thought we didn't really need eventually as we went through this. So we didn't really need to define the uni instance control, because it's really all governed by the ONU instance control. It's either 156 or 280. So the fixed bandwidth upstream parameter, we removed that from the technology profile, so that's not there anymore. And then the other parameters are kind of like we discussed before. So basically, the scheduling policy for the TCON, and then the number of gem ports I have for this particular service. And then for each gem port, I define what's the p-bit mapping association. Is it AES encryption is enabled or not? The scheduling policy, the priority and weight and discard policy. So all those apply to each of the gem ports. And then in the downstream direction, there's a similar option for a downstream scheduler. And also, in this case, where it says gem port, it's really a queue. So, but the queue has an association with a gem port in the downstream direction as well. So it's symmetric in that sense. So I can control the downstream scheduling policy as well. So again, this is just an example of defining the high-speed internet service basically with 1 gig upstream and 1 gig downstream. And this is where we kind of hit a bit of a hiccup in the implementation. Is that what we found was that because we were referencing the technology profile from the OpenFlow messages, what happened was we found that when the first table referenced the next transition table, and then the next transition table referenced the technology profile. So what happened was that in the upstream direction, the ONU gets table 0 information and with no tech profile. And the OLT gets table 1, and that has the tech profile reference. And then the opposite in the downstream, the OLT gets table 0 and no tech profile reference. And then the ONU gets table 1 with a tech profile reference. So we really need the tech profile reference in all the messages upstream and downstream. So that was a bit of a hiccup for us. So eventually we moved, after a lot of discussion, we kind of moved the tech profile reference into the metadata. So it wasn't a table reference anymore. It was just a piece of metadata that was associated with upstream and downstream flows. And that seemed to solve our problem there. How much time do I have left? I've got 6 minutes. Okay. So this is a little too detailed, I think, but let me just skip over this. Yeah, this is basically showing, what the flow looks like now. We've moved the technology profile information into the metadata. So it's, again, we have this wide 16-bit field now for technology profile identifiers. So we don't have to worry about squeezing things into a certain number of bits in the table ID. And this basically shows the application of a technology profile. So basically, in the downstream direction, we can define a flow scheduler and a certain set of queues, in this case 4. And in the upstream direction, we have TCON and gem ports. That shows the technology profile is applied in the downstream here, and the upstream and DBA scheduler. On the ONU itself, the technology profile defines the OMCI MEs that are generated, along with the match action rules that the OpenFlow has, and the bandwidth profile information. So the next issue we had was basically when this was being implemented on the Edgecore OLT, we had some issues with the BAL interface, allowing us to define the appropriate queuing and scheduling models. So this is what we wanted for a given flow. So we had basically in the downstream direction from the NNI, we had the flows mapped to 4 queues based on pbit. There was a flow scheduler where the bandwidth profile was implemented, and basically that went out onto the PON interface. What happened was we found that because we had to use an ONU scheduler, so as long as you only had one flow, you were good, because I apply my bandwidth profile to the ONU scheduler, and there's really no difference between scheduling at a flow level or scheduling at the ONU level. If I had more flows to schedule, then it would be an issue. And the other direction coming upstream, ideally what we wanted was a DBA scheduler that would then use the pbit on the packet to map to the NNI output queue. What happened was we found we had to basically have a flow spec rule for each individual pbit, and then that got mapped to one of 8 TM queues. And so in the end, basically, with BAL 3.x, all these issues have been addressed. So in the next 2.x stream, we should be able to define what we want in terms of upstream and downstream scheduling. So any questions?
How do you handle oversubscription
Oversubscription. Well, right now there's no parameters for that, right? So basically, if I have, it's basically the CIR that's allocated is managed, right? Oversubscription, the DBA algorithm will do its best, right? So if I have a lot of flows with 1 gig, then if the total is going to exceed 10 gig, then it's just going to schedule as best it can from the DBA algorithm. So basically, based on priority and the bandwidth components, it's going to do its best. Basically, it's supposed to be fair at a given priority. So all best effort traffic should get equal service, with a few caveats based on the standard, but it should be fair at a priority level. Okay. Okay. I guess I'm done.
Thanks, Shaun. They're clapping for you.
I'll take it.
And any question we have so far regarding to this? I think the implementation of technology profile was implemented in the VOLTHA 1.6. And then right now we're going to port the implementation into the VOLTHA 2.x. The initial release of the VOLTHA 2.0 does not have the inclusion of the technology profile implementation.
And in fact, the ONF created a brigade for this, so Sorov kind of led the brigade, and Gamze and Garish. Gamze works for Netseer, Garish worked for Radisys, and Sriju from Jabil also did a lot of testing with this, so that was good.
One question. So
no, we're over.
No. What about non-Broadcom-based OLT? The technology profile should also work. Is that correct?
Well, so then, you're going to have to map the technology profile parameters and meter band bandwidth parameters and the match action rules to whatever, whatever chip you might have for traffic management. So yeah.
Another question is, do you think the broadband forum definition of the traffic management is up to date today?
Yeah, I think as far as I can tell. I mean, all this basically came from the broadband forum. So. I thought there was a TR version. There was really. yeah.
There's an issue too.
Yeah.
Anybody else has any question? You can see a lot of reference of the YAM model and something from the broadband forum.
Yeah, it's all based on the standards, both broadband forum and ITU. Yeah.
Since we started meeting a little bit late, so I'll take a little bit of time.
Thanks. Hello.
Yeah.
You mentioned that VOLTHA 2.0 does not have technology profiles. Is that correct?
It does. It's being ported in, and we need the upgraded BAL interface to be able to fully implement the downstream and some of the upstream.
I guess my question was more for the earlier versions of VOLTHA or VOLTHA.
Oh, yeah.
What did you do for defining TCOMs and gems and that kind of stuff?
Before technology profile?
Yeah.
It was basically every service is one TCOM, one gem port.
Okay.
Any other questions?
Actually, I have the mic. So this obviously is tied to the Broadcom BAL implementation, which is Comron plus Maple. What would be required, I guess, it's a little bit like Shaun's question, to support other implementations, non-Broadcom implementations?
Well, so the OpenOLT adapter should be as it is, right? The OMCI messages should all be the same.
Right.
The question comes on the agent, the OpenOLT agent that runs on the physical OLT itself. So that would need to adapt to whatever traffic management capabilities that physical OLT had. So, I mean, the definition of the service is the same. The implementation under the covers needs to adapt to whatever the hardware can do.
Okay. So I guess these technology profiles, they're instantiated or manifested in what form? It's a file or?
Yeah, right now it's just a JSON-defined
JSON file?
Yeah.
Okay. So that wouldn't necessarily change, but
no, that should just stay the same.
Just the OLTs and the adapter that's implemented on the platform.
Right.
Okay.
So once an operator has defined a technology profile that matches his service, that just stays the same. And
Okay.
and it can use that same technology profile for every single ONU that uses that service. So if you only had one service, you'd need one technology profile.
Okay. All right. Thank you.
Okay, no, I have to cut the time. If you have any questions, please ask Shaun Missett. Thank you, Shaun. That's